Our solar system is a wondrous place with a single star, our sun, and everything that orbits around it: planets, moons, asteroids, and comets. What do we know about this beautiful solar system we call home? It's part of an even larger cosmos with billions of other solar systems.
Hi, I'm Jim Green, NASA's chief scientist, and this is Gravity Assist. With me today is Melinda Kahre, and she's from the NASA Ames Research Center. Now, Melinda manages the Mars Climate Modeling Center, which produces global climate maps of Mars. I mean, we are now predicting the weather on Mars, much like NASA and NOAA did in the late 60s, early 70s. We're making enormous progress understanding the climate of Mars. She's also an expert on Mars dust storms. So this is a fantastic opportunity to really understand what the heck is going on Mars today. Melinda, welcome.
Thanks, Jim.
Melinda, can you tell me what's going on in the Mars Climate Modeling Center? What is it and how does it work?
The Mars Climate Modeling Center is a group here at NASA Ames that develops climate codes, global Mars climate codes, to simulate the weather and climate on Mars.
Now that runs on supercomputers here. I mean, Ames has got some of the most fantastic, fast supercomputers from all of NASA.
Yeah, you know, we need super large computing power to be able to run our simulations that are very high resolution and have a lot of different physical processes in them that we are trying to accurately simulate for Mars. So yeah, we need the supercomputer here at NASA Ames.
Now, to accurately see what's going on Mars using your codes, you got to have input data. And so we've got several orbiters, and of course we've got weather stations on our rovers and landers on Mars in the past, and the two rovers, Opportunity and Curiosity, are still working. So what's the most important data sets that you really have to ingest into the models?
Well, we use data in a variety of ways for numerical modeling. Some data sets we use directly in the model, like the observed topography of Mars is a good example of that. And some data sets we use to compare model results to understand how realistic our simulations are. And one really good example of that is the maps of atmospheric dust that are coming back from the orbiters.
Wow. So you have certain grid sizes and you do a variety of modeling. So it's temperature, pressure, wind velocity. What are some of the other parameters that are so important to make these models work?
Yeah, it's everything that makes the climate of Mars run. So there are dynamical processes and physical processes. So on the dynamic side, we have winds and temperatures, pressures, densities. And on the physics side, we represent processes like dust lifting, cloud formation, radiative transfer, how energy affects the temperatures in the atmosphere and things like that.
Wow, sounds complicated, but how you guys make that work is really you bust it up into little modules and then connect them through the physics of how these things work together.
Yeah, we really do it piecemeal. So we look at one little bit at a time and develop each little section individually.
You know, let's talk about what's happening on Mars today. You know, there's a huge dust storm going on. It's a global dust storm. You know, and these dust storms going global, how often does that happen?
You know, not that often. The last global dust storm that we had was in 2007. So 11 years ago on Earth, but 6 Mars years ago. Generally, we see global storms on Mars maybe 1 out of every 3 years, but it's been a long time since we've had one this big.
Yeah, so we've been on a doofer for a while.
We have.
Yeah, so 2007, Curiosity hadn't landed, but Spirit and Opportunity were going strong. So that global dust storm in 2007, they managed to survive.
Yep, they did, both of them, and they observed the amount of dust in the atmosphere throughout that storm.
Right, and so that's a fascinating topic where we can actually get observations from the ground, looking up, seeing how the sunlight dims over time. Well, what's the composition of this dust?
These dust grains are mostly silicates, so plagioclase, feldspar, zeolite, and they also have some iron oxides, which is why they look a little bit red.
So how big are they? Is it like grains of sand on a beach?
Smaller than sand. We're talking 1.5 microns, 2 microns. So think really fine ash in size. These are
More-
small particles.
Yeah, more like house dust, right?
That's right.
You get in your
Yep.
house and you scrape that dust up off the shelves, and that could be what we see like on Mars.
Yep. Definitely dust particles. Pretty small little guys.
Well, one of the dust phenomena that I think we were really surprised to see when Spirit and Opportunity landed, because we thought, well, dust will settle out, it'll coat the solar panels, and the rovers, those two small rovers, will die after about 90 days. But a really neat phenomena happened in the atmosphere that changed all that. What was that?
There are small dust storms, dust devils, and also little wind gusts that came through and swept off the dust off the top of the rovers and off those solar panels.
Yeah, it's actually fascinating to see, and you see the power coming from the solar panels on Spirit and Opportunity go down, 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 down as it accumulates dust, and then one of these little dust devils goes by and it just peaks right up again, and then they start moving.
Mars helps out.
Yeah, it's really fascinating. You know, when we think about these dust storms, the dust is, as we said, really small, and then can be lofted. But there's also, dust that's a slightly larger and does get lofted a little bit, but then comes down. There's a certain way that dust moves over the planet. Can you describe a little bit how that happens?
Yeah, there are a few different ways that particles move depending on their size. So if a particle is really fine, like a dust grain, it can be lofted directly into the atmosphere, and it can enter into suspension, which means that it can blow around without coming back down to the ground too quickly. If you get a little bit bigger than that, you start talking about sand-sized particles, 100 microns or so, and those particles will leave the ground, but they won't get very far up in the air before they fall back down due to gravity. When those particles come back down, they can then hit the ground and splash smaller particles up into the air and into suspension. The final process is called creep, and those are large particles. So those particles don't really leave the ground, but they can kind of roll and bump along the surface a little bit. We think that saltation actually is the most likely mechanism for injecting dust into the atmosphere.
That's where they leave the ground and come back and then throw more particles up. It's sort of like a cascade.
Yeah, it focuses on sand-sized particles because those are the easiest to move, as it turns out. If particles are too big, they don't leave the ground because of gravity, and if they're too small, then they stick together on the ground and they're hard to get off the ground. So sand moves the most easily, and then it can come back down and splash small particles up.
So how high can these dust storms get?
In altitude.
Yeah, in altitude.
In altitude.
Right, yeah.
We see direct evidence of dust getting up to about 60 kilometers or more.
I mean, that's phenomenal when you think about it. That's so very high. I've also heard about, sometimes these get charged and then they will have a little spark. It'll be a little tiny lightning-like event, and that occasionally happens. There seems to be some indication from our rovers our orbiters that's happening.
Yeah, and that charged particle idea might also affect how dust is lifted off the ground. Some charge effects may change how easy or hard it is to lift particles.
Yeah, that's really fantastic. Well, now, once these get lofted, the dynamics in the atmosphere change too. What's the biggest thing that happens to the atmosphere during a dust storm?
Well, when you put these small dust particles into the atmosphere, they absorb solar radiation. So they absorb radiation and then they warm the atmosphere, and then they radiate in the infrared. So the atmosphere actually warms up. The middle of the atmosphere warms, and that warming causes changes to the dynamics to the wind fields, and the circulation is generally ramped up when you put a lot of dust in the atmosphere.
So during a diurnal cycle, the temperature on Mars can change like 150 or 60 degrees Fahrenheit. And then with the dust lofted, that change isn't so much, maybe a third of that.
Yeah, the diurnal cycle is suppressed if you look at surface temperatures. And that's because when you put dust in the atmosphere, it absorbs solar radiation during the daytime. So not as much sunlight gets down to the ground for warming. So the daytime temperatures are cooler with a lot of dust in the atmosphere. But then at night, those dust particles are radiating in the infrared down to the surface, and the surface is actually warmed at night. So the surface is warmer at night and cooler during the day. So the diurnal cycle is quite a bit smaller.
That whole effect is what Spirit and Opportunity enabled them to survive these long period dust storms. They go into hibernation, these rovers, and then fortunately the temperature doesn't get so low that it destroys the circuitry. So having that dust also warming the atmosphere, particularly at night, is critical. Okay, so what's different about our other rover, Curiosity, is that it's got a radioisotope power system, and it could just rain dust. It doesn't care. It's
doesn't need that sunlight.
Doesn't need the sunlight. Yeah, so that is one big advantage of having the RTG, we call it, radio thermal generator. Okay, so where's the dust coming from on Mars? Are there specific places where they start?
Dust storms actually are observed to start in a lot of different locations on Mars. Not every global storm starts in the same place, although a lot of them start in the southern hemisphere. This current dust storm actually started in a storm in the north that traveled then across the equator and started igniting lifting centers in the southern hemisphere. So we don't actually have a great handle on exactly where the surface dust is on Mars. We have good indications that there are dusty locations. The low thermal inertia regions near the equator have thick dust deposits. And we also know that there's a fair amount of dust in the polar regions.
But at the end of these dust storms, you've redistributed the dust across Mars once again, and so it's a matter of when the conditions are right to loft them in the new locations that they reside.
Yeah, it's a complex system for sure.
Yeah, we have to keep track of where the dust goes.
Yeah.
Well, another thing that fascinates me, Mars has got actually a fairly elliptical orbit, and my understanding is that dust storms start when the Sun and Mars are the closest.
That's right. It's Mars is closest to the Sun near southern summer solstice, and that tends to be when the circulation is the strongest to begin with.
So that's kind of the season we're entering right now. Is early spring into the summer in the southern hemisphere.
That's right.
So how long do these global dust storms last? What can we expect to happen next?
They last months. Actually, it takes a while for them to get going, and once they've reached their peak and dust is literally enshrouding the whole planet, we seem to see that the lifting centers stop operating, and then dust falls out slowly over time, and it can take months for that dust to come back down.
So recently I heard that maybe this particular dust storm it's reached its peak and may be waning. So we still are going to have several more weeks of this dust.
Yep, it's going to be up there for a while. The large particles will fall out first, and then the smaller particles will fall out more slowly.
So, some people have noticed that Mars looks a little more yellow at night. When they look up from Earth and see it, it's not as red as it used to be. And is that because of the dust storm going on?
Yeah, you can't really see the surface of Mars right now when you look at it with your naked eye or through a telescope from Earth. The whole planet is covered, the whole atmosphere is full of dust, which does change the color a little bit.
Does anything like this happen on Earth? Or do we? I don't know that we expect global dust storms, but some of the physics must be the same.
Yeah, we don't experience global dust storms here on Earth, but we do have dust storms on Earth and dust devils on Earth, and the physics is the same. We use what we learn from Earth and apply it to other places, and that's exactly how we attempt to understand how these things operate on Mars.
One of the fascinating things that we most recently found out about some of these Earth dust storms is as dust gets lofted and moves intercontinental, it actually takes microbes with them.
Yeah.
And so this is an exciting time for in Earth science when we make observations like that, and we don't know that that's happening on Mars. It probably isn't. We don't believe there's much life, if any, on the surface of Mars. But it's fascinating to think about how dust can also be used to loft life and move it around the planet. Well, one of the things that I always do, because I'm really fascinated by how each and every one of us get into the field of science that we're doing, and there's always some events that happen in our life that really propel us forward, straighten us out, and move us in a direction that allows us to become the scientists we are today. And I call that a gravity assist. So, Melinda, what is your gravity assist?
Well, it's actually hard for me to identify just one because I feel like I've had lots over the years. I got hooked on science in school when I was pretty young, actually, probably 6th or 7th grade. I took earth science and physics, and I loved science. I liked the process of science. And then I started taking an astronomy class when I went to college and got hooked on astronomy. And then I moved on into planetary when I went to grad school. And actually, the 2001 global storm happened the summer that I started grad school. And it, among other reasons, was why I was interested in studying Mars.
Wow. All right. Well, it comes full circle then,
It does.
it? Well, thank you very much. I've really enjoyed talking to you about what's going on at Mars, Melinda. Really wonderful.
Thank you very much. It's been fun.
I'm Jim Green, and this is your Gravity Assist.